checking 1, 2, 3. Right. Sorry about the delay. I tried to send out the link, but forgot that I have to send the unit circle too. So let me sign in real quick. Once again, sorry about the delay. I have to send the unit circle, and this time there's an attachment to it. Right. So now we go to chapter 4. Graphs of circular functions and periodic functions. Right. So when we go to the circular functions, I go back to when we define the trig function based on this. Just a second, I need to switch the line here a little. That's better. Alright, so we define the 6 trigonometric function based on the length of the arc. And in general, a trig function we define based on the length of the arc of the whole circle though, not just that. We define that for the whole circle. Now, the thing about the circle is that if we have a point, we go 2 pi, we get back to the same point. We can go in the reverse direction, still get back to the same point. So if it is at the same point, the x values and y values will be the same. So in that case, we can say that the function will be repeated, the values will be repeated after 2 pi. So that we call special case of the periodic function. Right. So I'm not going to write down everything. So a periodic function is defined to be the values of the function will be repeated after some period p. That means the y values will be the same. The x value will change after a period p. So it's good. So we have a periodic function. The function will repeat itself after some period. Next. Period of sine and cosine, and in the same token, the cosecant and secant. Right. Have I go back to the circle, the unit circle. Right. Now, once again, if it go one complete revolution, we get back to the same point. Therefore, the x values and the y value will stay the same if we go an extra revolution. Because of that, we can say for every real number t, sine of t plus 2 pi. So when we plus 2 pi to it, we get back to the same point. Therefore, the x, y, and r are the same, and the trig values will be the same. So after 2 pi, the values will repeat itself. At the same token, because secant and cosecant are reciprocal of each other, so we can also write cosecant after 2 pi will be the same, and secant after 2 pi will stay the same. Right. Because of this, we say the period for this function are 2 pi. So the period for this function at 2 pi, meaning that it will repeat itself after 2 pi. Right. Next. Period of tangent and cotangent. Now, I have to go back to the unit circle again. Now let's look at a point, for example. Focus on this point. Never mind, let's focus on this point. X values is square root of 3 over 2. Y value is 1/2. Now, consider this point and this point. What we did was we go at the protector here. So what we go is 180 degrees. From here to there. So 180 degrees or a pi from here to here. So the period for tangent and cotangent. Notice that this point is square 3 over 2 and 1/2. Those are the coordinates. The coordinate for this point is negative square root of 3 over 2 and negative 1/2. So we have to go from here to across the center 180 degrees or pi away from it. The x values negate, the y values negate. Because of that, the ratio of y over x will be the same. Because negative divided by negative is the same as positive divided by positive. So because of that, for tangent and cotangent, for every real number t, tangent of t plus pi is the same as tangent of t. Cotangent of t plus pi equal to cotangent of t. Right. So the period of tangent and cotangent are a pi. So for tangent, cotangent, the period is pi, everything else 2 pi. Right. So this is very important because when we graph the function, we just graph one period and then that will translate, will be the same. For example, I mean the graph is no big deal at all, but this section will study everything about the graph of the trig function. Right. The first one, the graph of y equal to sine x. Just gonna keep this for a moment. So the graph of it is no big deal at all. If we just want the graph, the calculator can do that too, but we have to study everything about it that the calculator doesn't care to know. Right, so just hit y equal to sine x and then graph. but no big deal, right? Now we need to change a lot of that, but first most important thing is make sure that when we hit mode, it has to be in radian mode. So mode, highlight radian, hit enter, so it have to be radian. Right. Now back to the graph. As you see, the graph just go up and down, up and down. Notice that the graph will repeat after this much, right? Or this much. So let's write out everything about the sin x. First of all, the domain, then the range, period, and zeros. Zero is where the function equal to 0. 0 is where we have sine x equal to 0. And over here we have the graph. Let's put that first. Now, it will be very difficult to do this. Of course, we look at the graph. I mean, up there, it is easy. But let's look at the graph in terms of the unit circle here. So, now, once again, we define sine is equal to the y values, right? So on the unit circle, let's focus on the y values. We start with this point, y equal to 0. I mean x equal to 1, y equal to 0, this point. So we focus on the y values. This point, x equal to 0, y equal to 1. So we have 0, 1, back to 0, and then 0, negative 1. So the sine function is the y values 0, 1, 0, and negative 1, right? And now let's just fill this in. Now, how do we determine the domain and the range? The domain, for every point on the unit circle, we can go around and around and around the circle. It doesn't matter where the point is. There is always the y values, and those are always there. So, doesn't matter where the point is. There's always the sine values. So the domain for the sine is all real numbers. Or we will say negative infinity to infinity. Right. Doesn't matter where the point is on the circle, there's always the y values. Right, the range. Now, if we define the y values for the point corresponding on the circle to be the sine, that y values cannot be more than 1, because at 1 it is the maximum. The y values cannot get outside of the circle. So the range is between negative 1 and 1. or we write interval notation, -1 to 1. Right, period. From the previous part of the section, we already know that 2 pi. So that's easy, right? Right. And then we flip to the unit circle. We start from 0, 1, 0, and -1. We're talking about the y values. 0, 1, 0, -1. So it will be equal to 0. Actually, I should draw a tiny circle here. Talking about the y values here and here will be equal to 0. So we say x equal to 0, pi, 2 pi also, or -pi. So in general, we have x equal to k pi. That's for the 0. Right. So that's what we have about the sine function. Now, in terms of the graph, notice that we go from 2 pi, the period, and then the range from -1 to 1. So if we want to graph, go back and change the windows. The period is 2 pi, right? So we'll go from, let's say, -2 pi to 2 pi. Right. Once again, hit Windows. The x go from -2 pi to 2 pi. Right. The scale. We'll get used to this, but for on the graph, usually we divide a period into 4 equal segments. So we will take 2 pi divided by 4. Always take the period divided by 4 for the increment. Right. The y values, we know y values only go from -1 to 1. So let's say we go from -2 to 2. That will be enough to graph it, and then the graph will look a lot better. Right. So we're going to do that same thing. So divide in 4 equal segments. The period is 2 pi. So we take a period, divide into 4 pieces. 2 pi cut in half is a pi. Cut in half again is pi over 2. And then 3 pi over 2. And then there will be -2 pi. So it's always look at the period and then divide into 4 equal segments. Right? And then for the range, go from -1 to 1. So let's say this is going from -1 to 1. And now we graph. On the side, 0, 1, 0, -1. So zero, 1, 0, -1, and it will go back to 0. So graph will go like this. I just sketch. because the period is 2 pi, so we can see that the graph for every 2 pi it will be the same. So that's why I just move that part to here, and I just keep extending to the right down to the left, so we just like a wave like that for the sine. So in order to graph, of course we have to know the period, we should know the range, and then the pattern of the sine, very important for the y equal to sine x. The pattern is going from the middle, max, middle, mean, and back to middle. So we go from the middle, max, middle, mean, and back to the middle. So that is the characteristic of the sine function. The cosine function will be different characteristic than this. So that is the graph of sine. Now let's go to the graph of cosine. Right, and we will have these 4 things too. Right, and on the graph of a trig function, right, now this will be quicker. Now we have a unit circle once again. Now the y values is the sine, the x values will be cosine. So again, if we go inside the circle, the x values cannot be more than 1 or -1. But doesn't matter where the point on the circle, we always have the values. So the domain for the cosine y equal to cosine of x is all real numbers, because doesn't matter where we are on the unit circle, there is always the x values for cosine. The range will be the same thing. From -1 to 1. And the period also the same thing, 2 pi. So those 3 things will be the same for sine, cosine. So what is the difference? What is the difference? Right. The difference is the zeros and the graph itself. So let's try to draw a little circle here. Cosine is the x values on the unit circle. So on the unit circle, when we are at this point or at this point, cosine equal to 0. So we have x equal to pi over 2, 3 pi over 2, and then so on. In general, we can say just pi over 2 plus k pi. In terms of graph though, it will be like that. On cosine is the x values. On the unit circle, x values is 1, 0, -1, and 0. So, as mentioned before, when we have the graph of a trig function, especially sine cosine, we go with the period first, 2 pi, and divide that into 4 equal segments. So always go with the period and then divide that into 4 equal segments. So this will be pi over 2 and 3 pi over 2. Right. The y values between -1 and 1. So the sine cosine look will be the same. The only thing different is on the cosine we start with 1 and then 0, -1, 0, and 1. So let's just get a little sketch here. And then the period is 2 pi, so that part I just save that over here. So the characteristic of the y equal to cosine x. Where's the orange? Oh. It starts from the maximum and going down. Maximum, middle, minimum, middle, and then back to max. So very important that we realize the pattern of sine and the pattern cosine is that y equal to sine x, this is increasing and this is decreasing. So the difference between the sine and cosine is just one start from 1 and decreasing, and the other one start from 0 and increasing. So one start from 0 and increasing, one start from 1 and decreasing. So those are the graphs of sine cosine. Now tangent is a little more complicated though. Right, now we go to the tangent x. We still have domain and range. Period. And then zeros. The difference is that in tangent we also have the vertical asymptotes. Right. And over here we have the graph as well. The graph of tangent is a little bit different. Let's see what is the graph of tangent. Right, so it's like that. Okay, back to that in a minute. But the first thing when we write y equal to tangent is that it's always we always have this y equal to tangent. Tangent is sine over cosine, right? We always have that. So when we write sine over cosine, if cosine equal to 0, then the function is undefined. If cosine equal to 0, divide by 0 is undefined. So because of that, the domain here, x cannot equal to 0. I mean cosine of x cannot equal to 0. Otherwise we divide by 0 and this is undefined. So cosine of x not equal to 0, meaning that this is not equal to 0. And the range. To determine the range, notice that we define in section 3.3 tangent is whatever the point is that intercept the tangent axis. So since it cut the circle, pretty much it can take any values. I mean tangent is this, sorry. So it pretty much will be the whole axis. Show the range for the tangent, as you see the graph on that, it go up and down. There's no bound for up and on the there's no bound on the top and the bottom. So the range will be all real numbers. It's negative infinity to infinity. Period. We did mention above, I mean previously, the period is going to be pi. For tangent, cotangent, the period is just a pi. And then the 0. Tangent equal to 0, meaning that the top is equal to 0. So the top equal to 0, make tangent equal to 0, and sine equal to 0 at k pi. And then the asymptote. The asymptote is where the function is undefined, so it's going to be pi over 2. It's going to be this. The asymptote is where the function undefined. And cosine equal to 0 when we have pi over 2 plus k pi. Right. So now the difference between this one and the previous one is that the period is just going to be a pi. So if we have to do the graph, we have to change the period to, let's say, from negative pi to pi. And the x scale, let's take pi divided by 4. Right, the graph will look like that. Right. Now we always have one period. It's a pi. For tangent and cotangent, we're not going to use these two. What the parents is based on the zeros and the vertical asymptotes. We have 0 when it equal to pi, so 0 is going to be here and here. And then the asymptotes will be where it's equal to pi over 2 and negative pi over 2. And if we want to, we can always graph. So there's the asymptote, and those are the zeros. And the graph will be for one period. That is, go from 0 approaching to the asymptotes and approaching to the asymptote. So this is the graph of one period. And we just copy and paste this throughout the whole axis. It will be like this. So that is the graph. By the way, if we want to graph better, we also have the point here. So technically we divide the interval from 0 to pi, a period, into 4 equal segments, and the pattern will be middle, which is 0, and then it will be increasing, and then there will be the vertical asymptote, and that's always increasing, and then back to the middle. So notice that the characteristic of the tangent function is that it is increasing. So now the graph, we know where the zeros are at the beginning and the end. The vertical asymptote right at the middle, and then we just have an increasing function, and that is the graph. And so it will be repeated every time. So if we zoom out, you get the idea that the graph of the tangent, those are periodic functions. They will just keep repeating over the bunch of intervals, and that's what we have. So these are the graphs of sine, cosine, and tangent. These are the characteristics of the graph. Those are very important. Bottom line is we always divide the period into 4 equal segments, and then we graph based on those. Next we go to even and odd functions. This is back in Cosine algebra. We define a function that is even is where the function of an opposite of a negative number is the same as the positive number. That's where it's even. And the function is odd. The function of a negative is a negative of the function. Right. So that's how we define it on Cosine algebra. And also we have the graph even function symmetric on the y-axis. Odd function asymmetric on the origin. Right. Now, with that in mind, when we look at this, the graph of sine and graph of cosine, which one is symmetric on which? Well, it's that the graph of cosine kind of mirror image of each other, right? So if you fold in half, the graph of the cosine will be on the top of the other, which is good. So cosine is symmetric on the y-axis, so cosine is an even function. An odd function is something that is symmetric on the origin, meaning that if there's a point there, there will be a point on the opposite. If there's a point here, there will be a point on the opposite from the origin. So with that, we have these very important things. Cosine and secant are even. And everything else is odd, meaning sine, cosecant, tangent, and cotangent are odd. And because of that, so when we have a function, we can see that there's kind of symmetry. So it's easy to graph if there's symmetry to it. For now, graph a circular function. Before we go there, let's take a 5-minute break. So we continue at 2:02. Right, we continue. Graph of cosecant. Now this will be a little more complicated. Notice that there will be no zeros, just the vertical asymptotes. Right. Notice that if we attempt to graph it on the calculator, there's no cosecant on the calculator. So we only can write that cosecant is 1 over sine. Now, we're just going to graph the y equal to sine x. Right. One thing we know that is the period. The period is for every other function than the tangent and cotangent, so just 2 pi. So the only thing we know for sure, this is going to be 2 pi, and that is very important. So I'm just going to start with that and try to sketch. Change just a little bit here. Ouch. So remember, period is 2 pi, and so we divide that into 4 equal segments. We do this a lot, almost on all the graph. Start with the period and then cut that into 4 equal segments. To which we have pi over 2 and 3 pi over 2. Everyone that will be on the other side as well. Now, first I will graph the y equal to sine x first. What I did was I'm going to graph y equal to sine x. So the pattern for sine, middle, max, middle, mean, middle. So middle, max, middle, mean, middle. The 2 pi is actually here, so that is the graph of sine x. And then of course that is the period, so translate or copy and paste this into here. So middle, max, middle, mean, back to the middle. So this is the graph of y equal to sine x. Easy, right? We know that the period 0 to 2 pi, divide that into 4 pieces. The maximum is 1, minimum is -1, and then just have to know the pattern for sine and then cosine. Right. Now, the interesting part here is for cosecant sine x, if the denominator equal to 0, the function is undefined. So the domain is whatever it is. Sin x cannot equal to 0. So based on the graph, cannot be 0, cannot be pi, cannot be 2 pi. So the domain is x not equal to k pi. And that is the domain. The complement to that is where it equal to k pi. The function is undefined. So the asymptote will be at k pi. So the domain and the vertical asymptote kind of opposite to each other. Because the function is, the domain is where the function defined, the vertical asymptote is where the function is undefined. So I have to say this, I should write that earlier too. So the domain is where the function is defined. And the vertical asymptote is where it is undefined. And in terms of the fraction, denominator equal to 0, undefined, denominator not equal to 0 is defined. So those are always opposite to each other. So we know the domain, we know the vertical asymptotes, and then the range. To end out answer the range, notice that we define secant is the cut. I mean in Greek that literally means cut. By cut I mean whatever the point is, it will cut on the outside of the circle. If the point is here, that will be the cut or the secant. Because of that, it is always bigger than 1 and it's always less than or less than -1. So the range will be greater than 1 or less than -1. Or we can say it negative infinity to 1 to -1, union from 1 to infinity. So those are all the characteristics of the cosecant function. But in terms of the graph, it's pretty simple. What we have is we always have to graph the reciprocal function. Graph the sign x first. Wherever it is equal to 0, there will be the vertical asymptotes. Wherever it is equal to 0, there is the vertical asymptote. And so just write when it is equal to 0, vertical asymptote. And then the graph of the secant, the graph of cosecant in relation to sine is this. When it equal to 1, 1 over 1 will be the same, also 1. So pretty much we have the graph of cosecant. Pretty much bouncing off the maximum and the minimum. So that is the graph of cosecant. Make a little bit darker. So the graph of the cosecant is just bouncing from the graph of sine. So if we can graph the sine function, definitely we can graph the cosecant. So whenever it is equal to 0, that's the vertical asymptotes. And then bouncing from the maximum and bouncing from the minimum. This is the cosecant function. We can do the same thing to graph the secant function. Because secant is 1 over cosine. Right. Domain, range, period, vertical asymptote, and then a bunch of vertical asymptotes. Right. Now, could do the same thing. The domain is wherever the denominator not equal to 0. And the vertical asymptote is where it is equal to 0. So those always opposite to each other. I should say complement to each other. And cosine equal to 0 at this point. So they're only different by that. The range will be similar to what we have above. Actually, exactly the same. Greater than 1 or less than -1. And then on the period is 2 pi. Right. Again, the period is 2 pi. So I'll divide that into 4 equal pieces. Pi, pi over 2, 3 pi over 2, and then 1, 2, 3, 4, -2 pi on the other side. Right, now first, since secant is equal 1 over cosine, I will graph the cosine function. And the cosine function, the pattern is maximum, middle, minimum, middle, max. So maximum, middle, minimum, middle, max. And then copy and paste that here. And this is the graph of y equal to cosine of x. Right, so if we can graph y equal to cosine, then we can graph secant easily. Whenever it is equal to 0, there will be the vertical asymptotes. So if we have a 0, that is the vertical asymptotes. So wherever the cosine equal to 0, we have the vertical asymptotes, and after that the function will bouncing from the maximum and bouncing from the minimum. The maximum here, so will bounce, it will bounce. So that is the graph of secant of x. Like I said, as long we can graph cosine, we can graph cosecant. If there's 0, vertical asymptotes. If there's maximum, bouncing above. If it's minimum, it's bouncing below. Right, so that is secant. Next, of course, we have is cotangent. That's the last function that we have. By the way, for the graph of cotangent, I'll look at the tangent and we'll do very similar to it. Cotangent, first of all, is cosine over sine. Right. Domain or range period zeros and vertical asymptotes. Right now, this is the graph of tangent. That's what we have. Right now, be very similar to this. The function is cosine over sine. The domain is wherever the denominator not equal to 0. And sin x equal to 0. If we look sin x equal to 0 is equal to k pi. So x not equal to k pi. The range similar to tangent be all real numbers. Period is a pi. So tangent, cotangent, period are pi. Everything else are 2 pi. Zeros. 0 is where the top equal to 0. meaning that x equal to pi over 2 plus k pi. And the vertical asymptotes is where the function undefined, meaning where sin x equal to 0, meaning that x equal to k pi. Alright. Now focus on the graph. Right. Up here is the pi. Divide that to 4 equal segments. One, two, three, and 4. Right. Now, the graph of cotangent. First, the vertical asymptote at multiple pi. So have the vertical asymptote right there and right there. And it will equal to 0 at pi over 2. So middle. Right. By the way, if we want the graph of cotangent, you just write graph 1 over tangent x. Right, so we have that. By the way, we should change the windows from negative pi to pi. Windows go from negative pi to pi. Always take the period divided by 4 for the increment. So that's what we have. Right. So we will have function like that. Right. Finally, the characteristic of cotangent x. We start from the vertical asymptote and then the decreasing to the middle. Keep decreasing and then until we hit the vertical asymptote again. So in comparison to tangent is start from the middle, increasing vertical asymptote and then increasing. So the characteristic of cotangent is it is a decreasing function. So for tangent, it is increasing and the vertical asymptote right in the middle. And the cotangent, it is decreasing and the vertical asymptotes on the end. 0 will be at the middle. So those are all the graph of all the 6 trig functions: sine, cosine, tangent, cosecant, secant, and then cotangent. First of all, this sounds like a lot of information for this section, and of course I agree to that, but we just need to know somewhat basic, very basic, is that the sine and the cosine, we have to know the pattern for the sine and the cosine, and the domain and range, so we know the sine cosine go like that. While we know sine cosine, secant and cosecant will be easy. We just bounce up the maximum and the minimum. So sine, cosine, secant and cosecant should be simple. The period is 2 pi. Tangent and cotangent are slightly different. The periods are pi. Tangent and cotangent. Anyway, when we go to the next section, we review a lot more. Now, amplitude and period. So this is section 4.2. Remember, we have to know what is the period first, so we can divide that into 4 equal segments, and then after that we can graph. If we have the, it will help if we have the graphing calculator to just get the idea of what the graph is supposed to look like. Right. First, the amplitude. Definition. Right. So first of all, let f be a periodic function, so it will be repeated. We define the big M is the maximum and the little m is the minimum. And after that, the amplitude is defined as the average of the difference of the maximum and the minimum. So I'll try to draw an example here. Let's say we have a function, either sine or cosine. We know that it's going to be wave like this. Except I draw terrible. Sorry. So either sine or cosine, we have the wave like that. So for that, we have the maximum values and then the minimum values. Oh, thank you. Yeah, it's easy to, I always forgot to do that. Thank you. Yeah, it's section 4.2. Right, so either sine or cosine, the graph will be a wave. There's a maximum, there's a minimum, and the amplitude is defined to be that distance from the middle to the maximum or from the middle to the minimum. This is called the amplitude. So the amplitude is from the middle to the max or from the middle to the mean, and that is the distance, so it's going to be positive. Right. Amplitude of circular functions. And this is only for sine and cosine. So for y equal to sine A, sorry. A sine x or y equal to A cosine x. So either A sine times sine x or A cosine x. The amplitude is equal to A, absolute values of A. And the range will be from a negative to a positive. This is only for sine and cosine. Whatever number is stand in front of it, it's going to be give us the amplitude, right? And then the other functions have no amplitude. Tangent, cotangent, secants, and cosecants. Have no amplitude. Simply because the graph of secant and cosecant, there's no maximum and there's no minimum. We have to have a maximum and a minimum in order to have the amplitude. Secant, cosecant, tangent, cotangent don't have the maximum or minimum, therefore no amplitude. Right, now we sketch. First graph y equal to 2 sin x. Right. In order to graph this function, we don't have to do everything like we did before. Like to do all of this. It will be a lot less. All we need to do is period, amplitude, and then maybe all the things. But first, what is the period? The first thing we determine. The period of sine is 2 pi multiplied by 2 in front of it. In 2 of the sine doesn't do anything. So the period is still 2 pi. Right, amplitude. The amplitude, whatever the coefficient of sine, we take, let's say amplitude is A, it's going to be absolute values of 2, which is 2. And then what we need for the sine is the parent. cosine, middle, max, middle, mean, and middle. That is very important. Pretty much we need that to graph. So start from the middle, go to max, back to middle, mean, and back to the middle. Right. I'm going to put the graph right in the middle here. So that's what we have for the graph. Next, the period is 2 pi. So let's pick 2 pi anywhere. So let's say if I'm going to choose 2 pi here, it's perfectly fine. Divide that into 4 equal pieces. Always take a period, divide into 4. So 1, 2, 3, 4. That's the period. Negative 2 pi. And then 1, 2, 3, 4. That's another period, 4 pi. 1, 2, 3, 4. Right, so when important that we know the period. 2 pi, 0 to 2 pi. Divide into 4 equal pieces. Pi, pi over 2, 3 pi over 2. Right, so we know the period, right? 2 pi, and then divide into 4 equal segments. Next, the amplitude is 2, meaning that it will be from the middle, go up 2, go down 2. So we just say, let's say 2 is here, and then negative 2. So the graph will bounce between the maximum of 2 and the minimum of negative 2. So it's bounded between negative 2 and 2. Because of that, we can say the range of the function will go from negative 2 to 2. Bound between negative 2 and 2. Right. So we say it between negative 2 and 2, and a period is 2 pi, right? So meaning that the graph of this segment would be just copy and paste throughout the whole interval. Right, so finally the pattern, we need to know that middle, max, middle, mean, back to the middle. So the graph of sin x, 2 sin x, it's not that bad, right? The period cut down to 4 segments, the amplitude, the top and the bottom, and then have to know the pattern here. Once we have one period, it's easy, just copy and paste middle, max, middle, mean, back to the middle. So the graph of 2 sin x pretty much just like this, and just keep copy and paste throughout. For every 2 pi, for every 2 pi, middle, max, middle, mean, back to the middle. So that is the graph of 2 sin x. Of course, we can graph for one period or more, but when we know one, we can just copy and paste throughout the whole graph, and that is the graph of 2 sine x. Just based on the amplitude will tell us maximum or the minimum, right? So it's not that bad. Next, graph of y equal to negative 3 cosine x. Right, and for sine cosine, need to determine what is the period and what is the amplitude. Always, if we just have sine and cosine of x, the period is going to be 2 pi. The amplitude will be absolute values of number of this number. Notice that the amplitude have to be positive. So it's going to be 3 instead of negative 3. Because of that, the range will be between negative 3 and 3. Right, and then just the pattern. The pattern for cosine start from the maximum, middle, minimum, middle, max. That's good. Except on this one we have an extra thing to worry about, which is the negative cosine. So pretty much when we throw in a negative, we have to flip all of this. So the pattern is max, middle, min, middle, and max. Now we go to the pattern of negative cosine. The pattern with the negative, the maximum become the minimum, the middle still stay the same, minimum becomes the max, middle stay the same, max become mean. So pretty much if there's a negative, the maximum becomes the minimum and the minimum becomes the maximum, the middle will stay in the middle. So that is the pattern of negative cosine x. Every time we have a negative, max is mean, mean is max, middle stay middle. Right. Let's go here. Right. Here is 2 pi. That's where we start. Say power here. So cut this into 4 equal pieces. Pi over 2, 3 pi over 2. Right. So that is here 2 pi. Add another 2 pi, give us 4 pi. Negative 2 pi, negative 4 pi. Right, so a period is 0 to 2 pi. There. Divide that into 4 equal segments. Right, amplitude is 3, meaning that 3 up and 3 down. So the graph for sine and cosine will be bouncing between these two functions. I mean these two, maximum and minimum. Kind of better. Yeah, amplitude is 3 up, 3 down from the middle line. Right. Now focus on one period. To pi. The pattern of negative cosine is the minimum, middle, maximum, middle, back to minimum. So that is one period. 2 pi, 0 to 2 pi, that. Now the rest is just copy and paste this for every period of 2 pi. Middle, min, middle, max, back to middle, go to minimum. Right, for every period, start from the minimum, middle, max, middle, min. That is the graph of negative 3 cosine x. There's a lot of graph today. Next, we'll just have the graph will bounce in between the maximum and minimum. Period. Now in general, sine, cosine, secant, cosecant are 2 pi. Tangent, cotangent are pi. So that's where we start with. Well, I have sine x, cosine x, secant, and cosecant. The period is 2 pi. Tangent and cotangent. The period is a pi. Right. By the way, just if instead of graphing 3 cosine, negative 3 cosine, and we graph negative 3 secant, instead of cosine we have secant, we just have bouncing up the maximum, bouncing up the minimum. It's still the same as before. Right. Now theorem. Right. Theorem. For the function suppose we have y equal to f of x, and this function has period p. Then for b, greater than 0, the graph of y equal to f of bx has the same shape. Of y equal to f of x, but the period equal to p over b. So that is one. So instead of sin x, cosine, secant, and cosecant, instead of that, if we multiply by a number, if we multiply the number in front of x, then the period notice that this function normally is 2 pi, but when we multiply by b, we're going to take that 2 pi by default, divide by the b, and then for tangent and cotangent, the period normally is a pi. Now just divide by b. Right. So if there's a number multiplied to it, just multiply, and then multiply by x, then the period will divide by that number. I think we need to do one example quickly. Try to sketch y equal to cosine of 2x. So to graph sine cosine, we only need to determine period, amplitude, and then the parent. The period normally it's going to be 2 pi. However, on this problem, there's a number in front of x. We have to divide by that. So it's always for sine, cosine, secant, cosecant, default is 2 pi, but if there's something in front of x, have to divide by that. So default is 2 pi, divide by 2, give us just a pi. Right, amplitude, the number in front of the function, will be just 1. So because of that, the range of the function from negative to positive of that amplitude. Right, the parent for cosine start from the maximum going down right. This time the period is the pi. We divide that into 4 equal segments. Always pi divided by 2 is pi over 2, and half of that pi over 4. So 0, pi over 4, pi over 2, and this is 3 pi over 4. Yeah, 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Reduce all of that. That's what we have. Right. So 1 period, 2 period, 1, 2 period. Right. Amplitude is 1. So 1 up, 1 down. And then 1 period. This case only from 0 to pi. Right, parent. Start from maximum for cosine, middle, minimum, middle, max. So right, and then copy and paste max, middle, mean, middle, max. Max, middle, mean, middle, max. As you see, I didn't draw that very well, but if we know the parent and then we know the period, if we divide that into 4 equal segments, at least we know the maximum and the middle and the minimum. Connect all of them actually make the graph a lot better than it actually is, because without knowing the parent, it's kind of difficult to graph, and the graph will look very bad. So bottom line is, we know the period, divide that into 4 pieces, we know the parent, we need to know that. And then the amplitude equals the maximum and the minimum. The graph, we're bouncing between those, and so that's what we have here. Apparently we run out of time, so we have to stop here. So let's pick it up on Thursday. Do you have any question before I end the stream? Other than that, have a nice day. See you on Thursday.